We're working through these problems, and last class, just to refresh your memory, did an endowment. With an endowment, it's 3 years, so you have 3 D's in the numerator, and you have an L in the numerator. The L and the last D both happen at time 3, because whether you're dead or alive, at the end of 3 years, you get your money back. That's what an endowment means. Endowment is something that pays you money if you're alive. And I said there's a way to simplify it. So to simplify, you have to realize that L53, people alive at age 53, plus D52 equals L52, which means you could take this entire thing and simplify it. And instead of doing D52, you could just do this whole last thing. Could just be L52. So adding the D53 and the L52, you can do them separately, or you can just add them together and use L52. So you can actually simplify it by replacing this with just that. It's the exact same thing. That's what that actuary did on that one exam. I thought, wow, that's pretty smart that he figured that out to save him a step in the calculation. You get the exact same answer. You can do it like this if you like. You'll get the same answer either way. But D52 versus L53, those alive at 53 plus those who died during their 52nd, obviously equals those alive at 52. You just substitute that. Since you're raising them both to the third, you can add them together and still do it. So that simplifies that particular formula. We'll practice maybe on Thursday doing a problem like this. It's time consuming, so we'll see how much class time we want to do, but they actually do a endowment, calculating the premium and walking through the steps. So we'll see Thursday night if we have time to do that. It's not too hard to do it in Excel. So if you have a laptop, it's a lot easier. You can't use a laptop on the exam, unfortunately, but it is the longest problem on the exam. The next problem, I don't want to do this one yet. We'll save it. This is one of the hardest ones I've asked, but I want to show the one I asked, I think last semester, I can't remember. So there'd be one of these crazy problems on the exam. It's worth a good chunk of the exam, so you don't want to leave it blank. So the key, and I haven't looked at this, so I just want to demonstrate that we can figure this out together. I don't know why I call it Uhr's Life Insurance Company. It's usually named after someone in the news, but they have a product that's issued at age 30. They're going to pay a premium at the beginning of age 30, 40, and 50. So we already know we're going to have L30, L40, and L50. It's paid at the beginning of the year. So you're in your time. This is going to be 0, that's going to be 10, and that's going to be 20. So you're going to discount these premium payers by 10 years, these premium payers by 20 years. So that's going to be pretty straightforward. It then pays a lump sum to anyone alive at the beginning of age 85. So L85. It's at the beginning of age 85, not at the end. If it's at the beginning, you just subtract. If it's at the end, you subtract, add 1. All right. We did that here, right? So the premiums are paid at the beginning of the year. So you take 40 minus 30 and you got 10. Premiums are paid at the beginning of the year. So you take 50 minus 30, you got 20. This payment's at the beginning of the year, so you take 85 minus 30, your end's going to be 55. Okay, anything at the beginning of the year, you subtract. Anything at the end of the year, you take that minus the beginning year plus 1. Right? So remember that, it keeps it fairly straightforward. All right, so those at 85 are going to get $1 million at the beginning of age 90. Those alive, what's that L gonna be? Someone just yell it out. I mean, what's that N gonna be, excuse me? 60, right? 90 minus 30, it's at the beginning of the year. And a death benefit at the end of year 99. D99, what's my N gonna be there? So you're gonna take 99 minus 30 and then do what? Plus 1. So it's gonna be 70. All right. So anything at the end of the year, you have to add 1 extra year. Anything at the beginning of the year, you just subtract. All right. We always pay our D's at the end of the year. We always pay our L's at the beginning of the year. We always collect our L's, our premiums at the beginning of the year. So L's, you just subtract. D's, you subtract and add 1. If you think about it, go back to our formula up here. D50, this was issued at age 50. D50, what do we raise this to? The first power, right? 50 minus 50 plus 1. What do we do here? 51. D51, 51 minus 50, that's 1 plus 1. You raise it to the second power. All right. See how that works. So death benefits, you got to subtract and add 1. Other benefits that were beginning of the year, going to just subtract. What's the payment going to be? So at age 85, it pays $1 million. At age 90, no wait, I said that wrong. It pays 500,000. Pays 500,000 to anyone alive at 85. $1 million anyone alive at age 90. And it pays 25 million to anyone who dies at the end. So if you make it to 99 and die at 99, you've made 500. You've received 500,000 bucks. You receive $1 million, and when you die, your family receives $25 million. If you die at 98, you get the 500,000, you get the million, but you don't get the 25 million. All right. So these are strange products. If you're 97, 98, your family's like, you got to make it. You got to make it 1 more year. So it sets up these kind of cliffhanging type of things. But yeah, if you can make it past your 98th and get into your 99th year, you got 25 million coming to your heirs. You won't get it because you'll be dead. Everybody's assumed to die at 99. Questions up to there? Then the question is, what are the values? So L30, we can go get that. L30, L40, L50, L85. And look at that. I mean, this is how this works. You got a lot of people paying premiums, but very few people are going to receive the cash. So if you're thinking about this, it sounds like this premium is being massive, right? You're paying people $26.5 million. They must have to have just a massive premium, but we'll see. L90s. Again, there's just not that many of them. And then the D99s, that's just anybody left. You're going to get that. All right. So if you think about this premium, you should be able to figure it out just by looking at it or get pretty close. You know you're going to pay L85. You're going to pay them 500,000. You're going to divide that by 1.05 raised to the 55. You're going to pay the L90s $1 million divided by 1.05 raised to the 60 plus D99 times 25 million divided by 1.05 raised to the 70. So you got to write that down. You should write it down on the exam because there's a good chance for math errors. If you get the equation correct, and I see you got everything lined up, you just made a math error, you can get full credit. I'm not going to, I'm assuming you can all multiply and divide. You're pretty good at that since second grade. So my main thing is get the formula set up. You're going to divide that by L30 plus L40 divided by 1.04 to the 10 plus L50 divided by 1.05 to the 20. Right. And you'll see all of that. So anything confusing in that, you'll see why I get frustrated when a student leaves it completely blank. Because you can look at it, at least anything that's paid out, whether they're alive or dead, is going to go on the numerator. Anyone who pays a premium is going to the denominator. If you keep that, you're going to probably get at least 30–40% credit just for putting the letters down. And then what do you pay out? Well, you take your L's or your D's times how much is paid out. Then all you got to do is make sure you get the right discount. Was the discount rate actually 5%? Excuse me, the discount rate's 4%. So I got to change all of these to 4%. So it's 4%. So sorry about that. All right, so let's try it. The issue is going to be, can I do it without messing up my parentheses? Did something wrong. What did I do wrong? Oh, let me start over again. So we want to do 18,000 people are going to get $500,000, but in today's dollars, for 55 years, that's what they're going to get. Then at 90, we're going to pay 6,683 people $1 million, but that's a very long time from now. That's 60 years from now. Then we're just going to pay out the lucky 111, or at least their heirs. They're not going to be very lucky, but their heirs. We're going to pay them the same 25 million, but for 70 years. All right. So there's our denominator. It's a massive number. But in present value terms, it doesn't look that big. When you discount something over 70 years, it gets pretty small. So we're going to divide that by the 99,000 plus 97,000 divided by 1.04. 104 to the 10th plus 92,007 divided by 1.04 to the 20th. There's your premium. Now I want to check it and see if it's right, something you can't do on the exam. I wish we could do this exam in Excel, then you could actually really check it, but let's try it. Try it on this sheet here. So our premium is that. All L's. Amount we're gonna pay 500,000, million, 25 million. So let's try it. So you got age is 30. You got cash in, cash out, and ending. So our cash in here is going to be all the people alive at 30 times that premium. We're going to have in that at the end of the period, we're going to have that times 1.04 because when do we get this premium? At the beginning of the year. So at the end of the year, we made 4%, so we're up to $924 million, right? Let's add 1 year. We got to go out to age 100. Too far. He won't make it that far. Go out the year 99. When do we get more cash in? What year? At 40. I agree. So what happens at 40? We get 97,000 people paying us 8,900. Here's our premium. I'm going to bring this forward. I should have added a column to do beginning balance. Here it's 0. Here, beginning balance, our ending balance. And we just keep making 4%. And here we'll make the beginning balance plus our premium, both going to make 4%. Everybody with me so far? Does that make sense? We're up to $2.2 billion. So it's a pretty good size insurance company. What happens next? Well, up until age 50, we just keep collecting this down. And at age 50, we get the L50s times $8,000, $9,000. So we carry that forward, and in here we add those two together, we get 4%. And that's the last of our money. This money has got to make those massive payments. So we copy this down. Someone say it out loud so I know you're with me. How far down do we go? When's our first payout? Say it loud so I know you're with me. 85. Age 85, we're going to pay out $500,000 to 18,000 people. We copy this down. I can't guarantee you I'm going to get the right answer, but we'll see. Copy this down. Then at age 85, we're going to spend, this is the beginning of the year, we're going to spend $18,000 times 500,000 bucks. So here we start with the 16 million and the 9 million is paid at the beginning of the year. So paid at the beginning of the year, we have to multiply them both by 4%. And when's my next period? L90, right? I'm hoping y'all are with me. You don't have to do this on exam, but it does somewhat prove. So L90, what happens? Hate hitting escape. We take the L90s and they each get $1 million. We're down to just $1 billion. And then at age 99, I don't know what I did in this column. This column is both cash in, cash out. It's both, so I don't need this column. unless I do that. So what's up above? Oh, all right. I don't need that column. Ah, yeah. Excuse me. You notice that's a really, really round looking number, isn't it? And when are we making this last payment? The beginning of the year or end of the year? End of the year. So it's probably going to be a really, really round number. How does that look? We multiply the opening by 4%, but we don't take that out. We get exactly zero. Bill Gates says it's something other than zero, but what does he know? So it works. Okay, so what do? We collected premiums at age 30, 40, and 50. We grew up our portfolio to $4 billion. We then paid out to livers, and then the dyers, and ended up with zero at the end. Again, it's a net premium, so that's the whole idea behind a net premium is you end up with zero at the end. Doesn't include expenses and profit and those type of things. All right. So you have two massive problems on the exam. One is this endowment, which just takes a long time to get all the calculations. And then this one, once you get it set up, you're in pretty good shape. I'd actually recommend you might do a table like this. What data do you need? What are your ends? How much are you paying out? And then what are the actual values of the else? You don't have to do it necessarily in that order, but it gives you the different pieces. All right, question. I can't tell you who's with me on this one. 1, 2 people out of 20. Y'all want to do another one? All right, let's look at another one. I'll go back an extra year here. Frank Harris, who's that? Y'all don't even remember him, do you? Anybody remember Frank Harris?
Beat him.
Yeah, we do. Well, they beat what's the name? I forget the name of this. They beat that 7-1 team. So
They beat them.
huh?
They did beat them.
Yeah, but I can't remember what team it is. It starts with an M, I think. But yeah, Frank Harris, is he playing pro at all? No. We had one student in my class who's going pro in basketball, but I haven't heard from him in a while. I need to text him and see how he's doing. He was texting me a lot there for a while, but I can't remember his name. Really, really good basketball player. All right, Frank Harris. So I'll tell you what, try to create the table I just created. All right, so list the L's and the D's you need, what your discount time is going to be, whether it's beginning of the year or end of the year. Remember, if it's an L, you just subtract 90 minus 30. If it's a D, you subtract and then you add 1. So write those down. And what are your payments? And then get the factors. So let's look through here. So Frank Harris developed a new product. It's issued at age 25. You pay a premium at the ages 25, 26, and 27. All right, write those down. You already know what those are going to be. This one's real similar to one I just showed you. I need to show you a different one. I have to find you a stranger one. What I can mix up is whether I'm paying the alive people or the dead people. I can mix that up. I can't say you pay the dead people at the beginning of the year. Livers are always at the beginning of the year. Dyers are always at the end of the year. That's the way it's structured. So I can't switch it and say pay the livers at the end of the year. All right. So you're going to pay people. You're going to pay them $10 million if they're alive at 95. $15 million alive at 96. A death benefit at the end of 99. This last part is pretty tricky. This is the tricky part. You're gonna pay 20 million at the end of the year 99 to those dying 97, 98, or 99. So people alive at 96, they get a benefit. So we're leaving out one group here. I made this one tricky. People alive at 90, well, really not. People alive at 96, they're gonna get $15 million. But everybody else, 97, 98, 99, they're gonna get paid. So that's everybody else that's left. But they're all gonna get paid, so their estates are gonna have to wait 3 years, all right? So make sure you're reading at the end of 99, they're all gonna get that final $20 million, but they have to wait. So if you die at the end of age 97, your estate will get $20 million, but they have to wait 2 years to get it, all right? So that's gonna influence what kind of N you use, all right? So they're gonna be paid at the end of age 99, all right? Y'all got it set up? All right, what do we need for the premium payers? L25. Keep giving them to you because I can't tell if you are with me. L26. L27. Anything else? As far as premium payers, anything else? So what's your N for L25? 0, 26, 1. All right. All right. Rob's with me. He may be the only one who gets it on the exam, but that's at least one person. All right. Payments, when we make payments. So is that a D95 or an L95? L95. So what's your N there? It's gonna be 70, right? Because it's paid at the beginning of the year. So 95 minus 25. Just remember that. Okay, how much are you gonna pay them? 10 million, right? What's my next L? L96. What's that gonna be? 71. That one's pretty straightforward. We're gonna pay them 15 million. And our last one. So let's put them all there. You have to decide how you do it. So you D97, D98, D99, but the N's going to be the same. What is the N going to be here? Well, you're going to take 99 minus 25 and then do what? Plus 1. So that's going to give you what? Essentially 100 minus 25. 75, 75, 75. All right. Now, if you missed that part of it, I would give you a lot of partial credit. I made it a little confusing. I do like to put a little twist into these sometimes just to make sure. And how much are you going to pay these people? 20 million. You don't have to do it 3 pieces. You could do it all at once and just add those all together if you wanted to. I'm in Excel, so it makes it easy. So let's go get the numbers off the table, the L25, 26 and 27, L95, L96, and then D97, D98, D99. These should equal L97 if you think about it. We added these 3 together. They add up to 720, 626. So if you wanted to, you could make this L97 and just do them all together, but you're gonna have to. So there's more than one way to do this. I'm gonna keep it like this. All right. So we got all the data we need. So now we just got to do the premiums. So, I mean, So then the denominator, anything you spend is gonna go out. So L95 times 10 million divided by, I forget what the discount rate was. 4%. I don't know why I'm using 4% on these. Divided by 1.04, that one's raised to the 70th plus L96 times 15 mil divided by 1.04 raised to the 71 plus, and we can just do L97 times 20 mil divided by 1.04 to the 75. This one is essentially the sum of those three. That's the L97, but it's still going to be 75. So you can do either way. You can do each one if you want, or you can just do the one. As long as you got the L7, that raised to the 75th, you're good. So all of that, and then the premium is real simple. You just have L25 plus L26 divided by 1.04 plus L27 divided by 1.04 this second. So if we set this up, got 10 million, 18 times 10 million divided by 1.4 raised to the 70th plus 1,017 times 15 million divided by 1.04 raised to the 71st plus those last dyers times 20 million divided by 1.04 to the 75th. Here's our numerator. $2 billion, that's a pretty big number. We're going to divide that by L25 plus L26 divided by 1.04, L27 divided by 1.04 raised to the second. Looks like almost the same premium. I didn't get too creative this year other than throwing that 375s in there. And then to test that one, our premium is that. Bring in our data. So I wish you could actually test it in here. So we'll do an age. We start off at 25. Got to go down quite a ways here up to age 99. Your beginning balance is 0. Cash. Beginning balance. Beginning balance is 0. We're going to collect premium from these people. For ending balance, it's going to be beginning balance plus the cash. Both of those are going to make 4%. Everybody understand that? It's paid at the beginning of the year. So if it's at the beginning of the year, you just added beginning balance, you give it 4%. Then your beginning balance the next year is that ending balance here. You're going to receive 99,823 times your premium, and your ending balance rose again. And then one last premium Your L27s times the 9,000. There's your last balance, $2 billion. Then your balance just grows until what year? All the way out to 95. So it's going to grow pretty enormously. Up to $40 billion. And here, what are you going to pay? You're going to pay minus 1518 times $10 million. That's going to come out of your balance. 96, you're going to pay 1,017 people, $15 million. It's going to come out of your balance. That's going to go on until age 90. Then at age 90, you're going to pay 626 people their estates, $20 million. So here we have to change the formula a little bit. The beginning balance times 1.04 plus how much is paid out. And what should happen if I hit enter here? Should equal 0. How do we do it? So obviously I'm not going to make you do this on the exam by hand. That would take you some time. You could simplify it some using, some future value calculations, but I'm not going to make you do that. But if you want to check it, you could check it. If you know future values, you could check it yourself. It would take you a little bit of time to do it. The first 3 years would be the toughest. And then once you get this ending balance, you're just going to raise that to whatever power to get you to that balance. And then you do the last few. So it would be possible. But again, it comes out to 0 at the end. All right. So on Thursday, I'll let you do it in Excel on Thursday, but make sure you realize on the exam, you're going to be doing it with paper and calculators. So make sure. I love students come up to me and like, where's my X to Y key on my calculator? So I would definitely be practicing this on your calculator to make sure you know how to do it. All right. Any questions on that? So essentially an X-ray can create almost anything they want to with these products. Some of these are really, really weird, but there's really no limit. I'm going to talk about my longevity product here and why I love it so much. I'll show it to you once we do the benefit of survivorship. It's not too much different than what I'm showing you here. You pay $9,000 for 3 years, and then if you live to be in your late 90s, you're set. I mean, if your portfolio runs out at age 95, and you're going to be in terrible shape, then this product's going to save you. You paid $30,000 earlier in your life. All those people that paid in, most of them have died. You get all of their money. So you get essentially $45 million. It's going to come in, and your estate's going to be really, really happy about that. Your beneficiaries. If you die at 94, your beneficiary is going to be really upset with you. So if you've been smoking into your 90s, you may want to stop for a couple of years, see if you can make it to 95. Making it to 95 would be nice. It'd be nice to really make it to really, your estate's probably hoping you die at 97. They have to wait. Well, I guess they don't really care, right? Either way, they probably don't care. Die at 99, they get to $20 million either way and at the same time. So there's no time value. So my job on the exam is to get creative enough that it's possible to solve, but maybe some little trick that you have to think about. But y'all can see it's really not that difficult. Right now, this doesn't seem too difficult. Thursday it is, because you're going to forget everything we just did. And then the exam is going to be really difficult because you're really going to forget everything. So you make a note in your class notes to come back to the video for this class right before the exam and watch this so you can have it fresh on your mind, okay? Especially how to get the end. So if it's an L, just subtract. If it's a D, subtract and add 1. As long as you remember that, it's very, very, very simple. Yeah, I don't like this product. This one was really too difficult. If you look at it, they developed a new product. It's issued for people age 60 who pay a premium of $49.55 at 60. So that's kind of strange. I'm giving you the premium. Then started at 97. It's just a horrible product. It pays an equal installment of 1.7 million at the beginning of each year and charges a premium at the beginning of the year that they're still alive. So it's just too strange because at the exact same time they're receiving 1.7 million, they're also paying a premium. And what you have to do is figure out that premium. So if you think about it, you got an L60, but here the L60, you already know you're going to pay $49.55. All right, so that one's already set up. You could just set that up in the formula, L60 times $49.55. You know, it's a little strange because I'm giving you a premium. That's why this one's so unusual. I probably won't give you anything like this. The rest of it's not too hard because you know L97, L98, L99, you're going to be paying out at the beginning of the year 1.7 million, and you're going to be receiving a premium. So it's essentially calculating that premium. But it is a tougher product. I can't, that might be the one I worked on the previous one. I can't remember. This is a different one. This is a third one. So you got three examples here. And I will save this to Canvas once we get to the end of it. So the one in your class notes is my least favorite one. A lot of students struggled with what to do with that 49.55. It's pretty tough. It's already a present value number, so you don't have to adjust it anyway, but you have to figure out how to handle it in your calculations, and it's a little bit tough. Here's the actual formula, but it's actually set up as an algebra problem, so you have to somewhat calculate what is the premium. But so it does have the answer at the end, but it says solve for the premium, which is really, really tough. All right, let's talk about joint life insurance. So this is our last product that we get the price. The problem I'm giving you is if one dies or the other one dies or they both die, they get a $10,000. What's the only way they don't get the money is if they both live. All right. So we can look at the probability that the wife dies and the husband lives, the probability that the wife lives and the husband dies, and the probability that they both die. But that's a lot of work. What's a lot easier to do is just calculate the probability that they both live, take 1 minus that. So 1 minus the probability they both live is when you have to pay out. So it's a really simple formula. It's the face of the policy, that $10,000 times 1 minus the probability they both live. The probability they both live is P70 times P90. So the husband's 70, the wife is 90. P70 times P90, that's the probability they both live. Does that seem strange that the husband's 70 and the wife is 90? I have a great aunt and uncle that are in that situation. They're not alive anymore, but he married her. He was 20 years younger and she was quite wealthy. I don't think he realized she was going to live into her late 90s. She might have outlived him, but she lived a long time. My grandmother passed away at 96, and all 3 of her siblings are at her funeral. Her 2 twin sisters and her brothers, her 2 older twin sisters and her brother were all at her funeral. So we got some longevity in there, but they were both still alive. His wife, the 90-something-year-old, she reminded me of Ava Gabor. She was just like this really, really fun person to be around. But anyway, so it's possible. He's probably not thinking she would still be alive at 90, but they're going to buy this policy. This is one of the questions as a short essay you got to write. I'm going to talk about the essay a little bit more this semester because students have really missed out on what the point I'm trying to make here. All right. So P70 times P90 is the same as L71 over L70 and L91 over L90. Multiply those 2 together. That's what P70 is. P70 is people alive at age 71 divided by the people alive at age 70. That's the probability that the 70-year-old makes it 1 more year. That's the probability of the 90-year-old makes it 1 year. You can't do the P's because they're not on the table. Well, they are, but it's better to do it this way. 1 minus that is what? The probability that either or both die. Okay? That times the face, and then you just divide it by 1 to the 1 plus the rate raised to the first power. So on the joint life, I'm only doing annual joint life. Make it really simple. You only have 1 year to go. It could get really complicated if we went out more than 1 year, but we just have 1 year we have to worry about. So do the calculation here. Oops. So we need L70, we need L71, we need L90, L91. We don't need D's because we're going to take 1 minus the probability of them both living. So we don't need that. There is one problem with this is if we have a husband and wife, we need 2 mortality tables. This is a CSO male table. I don't have a female table. So we're just going to use the male table for both because that's all we have. So L70, L71, and then L90. L91. So the probability both live is going to be L71 divided by L70 times L91 divided by L90. Any questions on that? People alive at 71 divided by people alive at 70. You can see how that's how many people live 1 more year. So the probability they both live, that divided by that, that by that. So they have a pretty good high probability that they both live because it's only 1 year. Then we want to do the probability one or both die. And that's pretty simple. It's just 1 minus. They have about a 25% chance that 1 or both of them will die, which is a pretty high probability. And that's going to be a key point. You're going to have to see this. 25% chance. If they were both in their 20s, probability that 1 or both would die would be really, really low. All right, so that's going to be key for looking at this product. All right. And so the premium is going to be 25% times 10,000 divided by 1.05. It's going to be the premium. I don't have it written quite like that in the notes, but there's that. There's the 25% right there. 1 minus those 2 things times the 10,000 divided by 105. So if we take that times 10,000 divided by 1.05, premium is going to be 2404.88. So what do you have to do on the exam? This one's a little tricky, but you can get it if you review it before the exam, because you're going to lose it if you don't look at it again between now and the exam. So what I want to do on the exam, so 2,400 bucks is what they have to pay. What I want you to do is compare this to buying 2 term policies. What if instead of buying this joint policy, they just bought 2 term policies? So what is the difference? So if the wife dies, they get 10,000 bucks, whether it's a joint policy are two-term policies. If the husband dies, they get $10,000 either way. What happens if they both die, though? Their estate would get what? $20,000. With a joint life, the estate gets 10,000. But if they have two-term policies, the estate gets 20,000. So the only difference is when both die. With two-term, they get 20,000. With joint life, they only get 10,000. So we can price these two terms. Term one is going to be D70 times $10,000 divided by 1.05 divided by L70. That's the formula we used before. The second term is going to be D90 times 10,000 divided by 1.5. So the first policy, D70 is going to be D70 minus D71 times 10,000 divided by 1.05 divided by L70. Here's your premium for that one. And your premium for this one, it's going to be D90 minus 91. That's, L90 minus 91. That's your D90 times $10,000 divided by 1.5 divided by your L90. Here's your premium there. So your premium for two joint policies is $2,704. What is the difference? The difference is the $2,700 minus the 24. So 290, let's see if I did it right. Let's check the difference. What's the difference going to be? It's going to be the probability both die times $10,000 divided by 1.05. What's the probability they both die? So this is the probability they both live. One minus that is not the probability they both die. That's the probability one or both of them die. So to get the probability they both die, we have to say probability of death. For this one, it's one minus that divided by that. So the chance he dies is 3.95%. The chance she dies is 22%. What's the chance they both die? Any guesses on that? Do you add them, subtract them, multiply them? Do you remember joint probabilities? What's the probability two things happen? You just multiply them. So the probability they both die is 0.876%. So if you take 0.876% times $10,000 divided by 1.05. Whoops, didn't work. You don't know why it didn't work. Yeah, I don't know what I did wrong. All right, we'll have to check this. That frustrates me. I always want to prove to you it's easy because I can just do it in class, and then every once in a while, my brain will make. I did that in my investment class the other day. I used 20 when I should have used 20 when I should use 40, and it dawned on me after class. So there's some, you might figure this out. You know, sometimes I'll do it on purpose to see if you're paying attention. mean, the key here is there's a 25% chance one or both die. The probability they both die is much, much, much lower. I think I got that right. 1 minus L71 over L70, that is the probability he dies. That is the probability she dies. Probability he lives is 1 minus that. So, yeah, I'm not. Probability they both live should be our 75%. So we got that already. Probability that she dies, but he lives. Probability that he dies and she lives, or either ways, we add those up. We should get the 25%, and we do. So I'm not real sure. Probably this formula down here is the issue. All right, I'll have to figure it out. I'll figure it out and show it to you next class so we can get a little more practice on this. But anyway, you see the theory here. What I'll do next class is I'll show you with younger people. Once I figure out what's wrong with my formula, I'll show you with younger people. So the real key for your essay is joint life never makes sense for young people. Just by 2-term policies. Now, so I'll show you next class. I'll demonstrate it once I figure out my math area here, unless one of y'all has figured it out. So joint life doesn't make sense because the difference in the premium is going to be a probability they both die. What's the probability 2 20-year-olds are going to die? It's practically 0. And so the difference in the premiums is going to be maybe a penny or two. You're not saving any money by buying the joint life. The joint life makes sense. Seniors, if the savings are needed. So in this case, I don't know which one's the savings. Let's see if it's in the class notes. Is it possible that it's in the class notes? Yeah, I didn't put it in there, so. Boy, I don't see an obvious error. So either way, whether it's $83 or $300, obviously 300 is a big savings.
For term 2, did you mean to multiply times the 105 and the L90? Or
Oh, I was supposed to divide by 105. That's probably the difference. Ah, thank you. Okay, Juan Carlos gets an A+ for the class, unless I change my mind later. No, good, very good. Ah, good. Okay, 83. I was thinking 83 is probably the better one. All right, so yeah, I accidentally multiplied by 105 instead of divide. Good catch. I don't see how you cut that, but you got good eyes. All right, so 83 is not a lot of money, but you know, so the key here is it doesn't make sense for young people. For senior citizens, it makes sense for senior citizens, but it depends on the purpose. The insurance. Do you care if beneficiaries get 20,000 if both die? And you may not care, right? 10,000 is what you need to pay for funeral costs. If you both die, maybe you say, hey, we do need 10,000 because I got to pay for 2 funerals. You got to ask, what's the purpose of this? If the purpose of the joint life is to make sure when one dies, the other one has money, if that's your only purpose, then buy the joint life and save the 83 bucks. But if your beneficiaries for some reason need more money if you both die together, and that would be a big burden, then yeah, pay the extra 83 bucks so that if you both die, they got 20,000 bucks, they can bury you both or something. So it kind of depends on that purpose. 83 bucks is not a lot of money, but it is something. The policy is only for 10,000 bucks, so it's not a very big policy. It's expensive because they're both so old. Um, so, so I will, I want to do it now, but on Thursday, I will show you, um, I'll show you, sometimes the difference is barely even a penny. It depends on how big the face is, but, so I'll show you that one next time, but that's the joint life. So there's a short paragraph. The key is I do want you to calculate this difference. Now, if you make a math error like I did, I mean, that's fine, but the key is what are the two term policies cost? They're going to be more expensive than the joint, all because of that one difference. There's one scenario where the two term policy will pay twice as much as the joint. And that's the only difference in the premiums. So joint life is almost entirely two married couples. And if one dies, the other one's going to struggle. Maybe they both have pensions. And if one dies, the other, that pension goes away and the other one loses that pension and they need some money to make up for that pension or something like that. You know, there's usually something along those lines. They're usually not focused on the beneficiaries saying, wow, if we both die, we better give them twice as much money. That's usually not the case. So saving $83 is usually what you want to do. This insurance is very, very expensive. So anything you help cut the costs. Granted, it's not a massive savings. It's 3% savings, so it's not huge. But you know, if it's $100,000 policy, it would save you $800, but it'd be a very, very expensive policy. So a short paragraph, pretty simple paragraph. Do point out that for young people under the age probably of 40, I would say, just doesn't make sense to buy the joint life. This is almost exclusively a policy for older adults. And because you have to have it all comes down to this probability they both die. Even here, it's less than 1%. So with a really young person, you're talking about something that's practically impossible. Now, what do actuaries actually do? So I don't know. I don't have an actuary to talk to on joint life. You do have the issue that these are not independent lives. They do live together. They do drive together. They do fly together. Do the actuaries adjust for that? I haven't been able to catch an actuary. If any of y'all know some actuaries, want to ask that question, get back to me. I'd be fascinated to know on a joint life if they put in the probability that they both dying would actually be higher. The joint life you think you wouldn't carry because you're paying out $10,000 either way. But I don't know if they take that in consideration when they're insuring lives. But so the actual probability that they'll both die is probably a little higher than 0.876% because they are moving around together, everything they do. So the chances of both dying probably is a little bit higher, but I don't know how to calculate that. And it's probably not even material in that case. If you think through how often you've seen two people die at the same time. Now it is pretty common, especially if the wife dies first or the husband will die very quickly afterwards. And in that case, but in that case, the joint life doesn't cover. I mean, it's looking, once the first person dies, that's the end of the policy, pays $10,000. So that would really be more of an issue for the two joint life, but all right. So we'll do a little bit more work on that. So joint life does have some issues. If it's a first to die policy and they have children from different marriages, it can get pretty material because whoever dies first, the survivor gets the life insurance. So let's say they're in a car accident and they both die. Now the insurance company has to decide who died first within a second. Because if the husband died first, the life insurance goes to the wife and to her estate. The wife dies first, the insurance goes to the husband and his estate. So if they die almost at the same time, you got to figure out who died first so they can figure out which estate that goes to. So yeah, I don't know how often that's happened. Historically, I'm sure it's happened at least once, and that can be an issue. All right, so as we just said, younger people should buy two term policies. There's just no savings. older people, it just depends. You save more because they're older, because it's a higher probability they both die. So you just need to ask, why are you buying the insurance? Do you care? Does it make a difference if you both die at the same time? Is that significant? Are you thinking about that? If that were to happen, would that put any kind of extra burden onto your beneficiaries? If that's the case, then maybe buy the 2-term policy so you have twice as much. If not, just buy the joint and save the money. Buy the joint life. I should say joint life. Saying buy the joint sounds bad. College setting. Questions on joint life? I don't think this is sold all that much, but it is out there. So companies can sell that. Okay. Just a few articles on mortality. We might get into mortality tables a little next class. We'll see, or maybe the class after next. All right, so we know women live longer than men. Pre-COVID, so this is some statistics pre-COVID, and we know it's changing. There's been some things here recently with men that has actually been impacting men. So I don't have a more up-to-date article. This one's pretty old, but just to show this is an issue in longevity. So men were, up until the last 5 years, probably catching up with women's, and it wasn't that women were living shorter. It was, although there is a little bit of that, but it really was men were living longer. Men were doing much better. So the women tend to live longer than men, but it's less true than it used to be, at least at the time this article was written. The difference between life expectancies in England was 6.3 years in 1967. Now it's 4 years. In the early 1980s, women who made it to 65, the traditional age of retirement, could expect to live 4 years longer than the male counterparts. The gap is now less than 3 years. So you can see the gap is shrinking. I remember seeing one article that in Britain, well, I don't know, this is years old, but there's an 8-to-1 women to men at age 85. So I was thinking, I think at 85, I should just move to Britain. Boy, there's going to be some rich British woman that's going to be like, man, you're ugly, but I got 8-to-1 outnumbered. I'll take you. It would be pretty good odds. But it looks like those odds are getting worse. So who knows? Still be there. The trend is superimposed on another one, that life expectancy in countries has been improving. Again, COVID. I forget the drug everybody's using now. I don't do no drugs. What's the drug? Fentanyl coming up from Latin America, and now it's a synthetic drug, right? They're making it with chemicals. That's shortening life expectancy. There's things that are actually impacting these. And then COVID, obviously, life expectancy has been improving for both, but it's been improving more for men than for women. It's not like the women are getting worse or that they froze, it's just men are catching up. Half the difference is smoking. So men have stopped smoking. Men were much more likely to be smokers than women, but they have also been more likely than women to give up cigarettes the last half century. A further fifth, the longevity gap is explained by alcohol. The gap is widening. Men who died from alcoholic causes. So that's actually increasing the other direction. Although your generation is drinking less than previous generations. But using, it's strange. There's been a shift in drug use from alcohol and drugs. So who knows what that's going to do. Another factor is obesity, maybe have greater impact on women because it increases the risk of both hypertension and diabetes more than for men. And men are also closing the gap in another area related to obesity and coronary heart disease, deaths. And this is kind of the medical community jumping in. Deaths from this fell more than 50% for both men and women, but because heart disease affects men more than women, that 50% drop really helped men's mortality more. And who knows? I mean, we're in a major revolution right now on food and exercise and fasting and all these kind of things. Who knows what's going to happen, if that's going to impact men or women more. I've been seeing articles, and everybody's in the fasting now, but that fasting is more dangerous for women than for men. And so there's like these warnings for women in fasting. Make sure you you watch out for this that they don't say for men. So who knows? We're in this revolution, and who knows what, if you're an actuary, this is pretty important. You got this revolution with this new diet drug. You got people protesting food companies for processed food. People are changing their diets. It's amazing to me the number of people my age that are losing weight and keeping it off for the first time in their lives. It's like overnight, people have finally figured out the equation. And it's mad. People who struggled for 30, 40 years, and finally it just happened. So who knows what all this is going to happen. So if I'm a life actuary, I'm looking at that really closely. What's going on here? People are changing their behavior, they're changing their diets, they're changing their exercise routines. I mean, it's pretty massive. So I think it's more my generation, but I was talking to some students in my investment class, 20-year-olds, and they're repeating everything I was hearing. So everybody's, I don't know if y'all are seeing these videos, but they're going pretty wild. There's not 100% consensus, but there's probably 85, 90% consensus. Get rid of flour, get rid of processed foods, get rid of carbs, get rid of sugar, added sugar, get rid of artificial sweeteners. I mean, it's the food industry is the culprit here. So it'll be interesting to see what these numbers do. So there are biological differences. So you can read all that. Testosterone promotes more aggressive. So obviously men don't make it as long because a lot of them don't make it past 30 because men do stupider stuff when they're younger than women. It's like in P&C class, I don't know if y'all remember my P&C class, but there's this British advertisement saying, telling boys to drive like girls, so that was going to somehow encourage them to be safer drivers. And I thought, I don't think a 17-year-old boy is going to be encouraged to change his driving behavior, tell him to drive like a girl. Doesn't sound like something that would have worked in my high school, but suicide is obviously a big issue for men, and that's probably has been an issue more in the last few years. And there's actually a longevity science panel in the UK. Let's see if it's still there. Last class I checked, it was still around. I mean, did you know there was such a thing? There it is, the longevity science panel. I don't know when the last time they updated something. They don't have any dates on here. Not much to it. Members, latest report. Let's try that. What is their latest report? And nothing. Their latest report. Yeah, this is probably one of these that hasn't been updated in 20 years. I wonder if any of them are still alive. That would be ironic if none of them are still living on a longevity. Reckons that even if men adopt healthy lifestyles, women continue to outlive them. So, all right. How long will you live? Okay, this is just a curiosity article. We'll start here next class. So we'll start on this one. All right, what we'll do next class, we'll work, so it's practice for the exam. Come in, I'll let you look at your notes. It really, really helps for the memory, the work, and struggle through some problems. We'll work some problems from previous exams, give you some practice, and then we'll finish up and get into my favorite topic, which is asset liability management. All right, we'll stop it there. Thanks. All right, so we're gonna do some practicing tonight. So I brought some. So what I recommend is get some blank paper and work these using your calculator. We do one at a time. I'm going to get you started. We're getting ready for the final, which is not that far away. I know it seems like it's after Thanksgiving, so it's like 4 years away, but it's not that far away. But we'll walk through each one of them. This is going to be time consuming. Why don't you be ready for exam? I recommend you do it on a separate piece of paper. And then when we write the answer, write the correct answer on the paper with the steps. So you have something to take to with the exam practice. You have it all written out, because tonight it might seem pretty easy, but you're not going to sit again for 3 weeks. So this is the type of question that, that kind of stuff where you got it, and then next time you look at it, it's like you've never seen it before. So we got to get you something so you get prepared. So if you want to come pick these up, if you want to do it on your Excel, that's fine, but you can't do that on exam. So I recommend you make sure you can do it in your calculator. This first one is an endowment, and it's 3 years. So how many things are in the numerator? How many payouts are you gonna do? How many Ds in a numerator? Well, 3 Ds and 1L, all right? Or 2 Ds and 1L, depending how you do it. Remember we said you could make the shortcut. So on endowment, so anytime it says 3 years on life insurance, it's gonna be 3 Ds. The endowment, you also pay the liver, so it's gonna be 3 Ds and 1L, all right? How many premium payments? Well, if I don't tell you, the denominator is gonna have the same number as the policy. So if it's a 3-year policy, you're gonna have 3 Ls in the denominator, right? And this one, I also want you to do the flow, which is it's time consuming, so we're gonna have to get into it tonight, but I wanna make sure you feel comfortable exactly what the exam is asking for. So do your best to set it up. On the exam, I'd recommend you write it all out as symbols so they can see you know the formula, and then if you make a mistake, you just pull the wrong number from the mortality table. I can give you credit. I can't give you credit if you get the wrong answer. I don't know what you missed. You have to show me, so show your work. All right, so I'll just let you go. If you have questions, you just can't get started, then, raise your hand and I'll give you more hints or show you in the notes where you can look. Let's check the formula first. Who's got the formula? Just without does anybody have the premium yet? No? What's in the numerator? And the numerator? E40 times 500. All right, y'all see that? That's your first payout. It's exactly right from your, okay, then what?
Plus 13.41 or 13.41 times 500 divided by 4%.
Okay.
15 times 500 divided by 1.0.
Okay.
And then add L50, well, L40.
Oh, 40, 43, L43. Times 500. $1.04 to the 3rd again. All right, so there's the numerator. Okay, and then what's the denominator? Denominators are always a lot easier. Acres on the denominator.
L40
40.
plus L41 by 1.04
All right.
plus L42 divided by 1.04 second.
Yeah, so that's your formula. Let's keep working on it. If you get a dollar amount. When you don't show the transactions, you might only get the first year or two done. So if you don't finish it, we'll finish it in here. The key is that you get it set up correctly. All right, try to get the right premium. It's a lot of numbers, I realize. It's a lot of calculating.
What decimal do you think would be best to round to?
Well, it depends on which part you're looking at. I think you can go out 2. You might almost be able to go out with no decimals. I don't count off for rounding. It does hurt you when you're doing the flow. If you don't go out 2 decimal places, you can be off so much it makes you nervous. But even then it'd be okay. So try to go 2 decimal places. That keeps it from being 2. I wouldn't go more than 2. Now, if you're not great at the raising to the power, it's not that hard. Just take B41 times 500 divided by 1.04 divided by 1.04. You don't have to square. You don't have to do it, but you only have to do it 3 times. So if you want to ignore the square and the raise to the power, just keep dividing the number of times. Has anyone gotten 154, 50? You did? Okay. Okay. We'll go with 154.54. All right. And try to double check. You got in the ballpark, you're probably okay. If you're just one number off, you don't lose anything. But you can see the way I have the problem set out. So you might think about setting out your answers like that, just putting all the detail down so that it makes it easy to see where it went off. But all right, so now try let's do a little bit of the payout. So you have time 0. You have time 1, time 2, time 3. Times 1 and 2 are exactly the same. So what happens in time 1? Everybody remember? So you collect the premium. Even before that, what happens at time 0? You collect the premium, right? What do you do with the premium? Invest the premium. And then nothing else happens at time 0. What happens the first thing at time 1? Investment. 1 year forward. Collect your premium. What happens after you collect your premium? Before you can invest, you got to pay out something. What are you going to do there? Death claims to whom? Who pays this premium here? Who pays the very first premium? Any takers? First premium? What's in your denominator? What's the first thing in your denominator? Oh, 40, right? Oh, 40 times the premium. You're going to press this at 4%. All right. Who pays the premium here? It's in year 1. Oh, 41 times your premium. And to whom do you pay the death claim? These both happen. You know, you almost put the death claim first. If you think about it, these people die at the end of the year, and then you collect your premium at the beginning of the next year. They happen almost simultaneously, but you technically pay the death claim first. So to whom do you pay this death claim? What does your numerator say? D40, right? So D40 times 500. You collect the premium, and then you invest the net. And your time 2 is going to be exactly the same. Except for now you're going to pay death claim, the D41, and collect premium from L42. Then at time 3, starts off the same. You've collected 1, 2, 3 premiums, so you don't have any more premiums, right? So the paid death claim makes sense. How many you pay for it? Here, you paid D40, you paid D41. What do you have left? D42 and L43, right? Pay delivers. So that's L43 times 500. And net, you might put something like this. Should be 0. You know it won't be because of rounding. But so see if you can get one or 2 years set up, and then I'll show you the balance. At least get it, since years 1 and 2 are the same. See if you can at least get through the end of year 1. And I'll show you what the net should be at the end of year 1. So I wish we could do this exam in Excel. That'd be much better. Then you know you tie exactly to the penny. I'm sorry? All right, so here's what I have. Collective premium, I got right at $15 billion, $14,997. That's using the premium 154.69. Oh, I know where it went. There it is. So you bring that forward at 4%. So you just multiply by 1.04. You pay the death claim, D40 times $500. You collect your next premium, L41 times to 154. So you take your beginning balance, subtract what you paid, add the next premium. You have an ending balance of 30 million. You bring that forward at 4%. You pay the D42 or D41 times 115 times $500. Collect another premium. You got 46 million. Bring that forward at 4%. Pay the D42s. Pay the L43s, and you should have a 0 at the end. R with the rounding, I was off by 56 bucks. So that's what it should look like there. Any questions on that? Anybody get in the ballpark?
What is that?
All right, so here's the formula that goes with the problem. So it says calculate, do, solve, and so that's going to equal 154.69 or somewhere around there, depends on how you round. And then the second part of the question says, show the flow of transactions. So at time 0, what happens? You collect that premium for the L from the L40s, L40 times 154. That's all you do at time 0. At the end of time 1, you make 4% on that. You pay a death claim of the D40s times $500. You collect the premiums from the L41s, L41 times $154. You take the 15 million minus the 147 plus the 14,951. That ends up at 30,401,000. You then take that 30,401 and multiply it by 1.04. That's your portfolio at the end of time, at the beginning of time 2. You pay your death benefits. L41, where are we? 142 times $500. D42 times that. So this is, no, that's D41, D40, D41, D42. So this is D41 times $500. You collect the premium from L40. Boy, I'm losing track. So L40, L41, L42. So this is D41, L42. So you'll always be off by 1 year on your D's and L's. The D's will be 42, the L's be L40. I mean, the D's will be 41, the L's be 42. So the L's will always be 1 year later. Collect that premium, L42 times 154, D41 times $500, 30 million minus 159 plus 14,902 equals 46. You multiply that by 104, you pay the D42s, 171, you pay the L43s, 48 million. So most of those are about 500 bucks. And you should end up with something close to 0 at the end. I mean, I'll put this out on Canvas so you have it to practice with. It takes some practice, but you see it gets really redundant once you get one set up. See?
And for this example, is growing out of 5%.
No, it's 4%, I think is what the question said, right?
The
4%.
growth rate, I don't know if it was just.
Yes.
It's lower down, it's at 5%. It's at the top of your whole flow.
Yeah, where did I say?
Yeah, if you write a little cut premium, it's 5%.
I don't know where I put it, but
It was under your time 0.
oh yeah, that's a typo. Sorry. I can fix that though. Let me put, so this is L40. Let me fix some of this a little bit and I'll repaste it. Which D is this? Your first D is D40, right? Like your premium from L41. So you notice they're always a year off. It happened at the exact same time. Why? Because you pay your D's at the end of the year, you collect your L's at the beginning of the next year. That's exactly the same time, essentially. Well, I don't do the 1 till 04 until time 1. Because at time 0, you haven't made anything. You just invested it.
So you're just taking our L40 was by our view.
Right. That's all that is. And at time 1, you take that premium and multiply by 1.04 because you've had it for a year. So this 15,596 is that 14 million plus the 4%.
For this case, our L40 is 97,043, right?
97,043, right?
You just multiply that by 154.6.
Right. That should get you 14,997. You can test it.
2015.
And that's the same for like each collector premium, like.
Yeah, L41 times 154. That should be 96,749 times 154.69.
But like the later years, we don't have to raise its power. Right?
Well, all of these are in current dollar. You pay the death claim in at $500. The time value money comes in with the portfolio and how that moves forward because you're netting these out. So you're going to pay them $500. You're going to collect 154. There's no adjustment.
So we're only finding the like the gross rate on the net remaining.
Yeah, because that's your portfolio, right? You have this portfolio, you're gonna invest at 4%. Sorry, I keep saying 4%. You pay exactly the $500, you receive exactly 154. There's no time adjustment there. That's once in the contract, right? The face of the contract's $500 and the premium is set for 3 years. So there's no time value there. The time value is what you have to invest in the portfolio. Right, is it getting a little more comfortable? It really is pretty redundant once you do it a few times. The problems don't. It's a bunch of D's in the numerator, a bunch of L's in the denominator. You just got to figure out how many D's and how many L's. Most of the problems you don't calculate. All you do is show me the formula. So most of the problems, the only thing I need is this. You have 3 you got to calculate on, and that's the 3 I gave you here. All the rest, just give me the D's and L's. So fairly straightforward. All right. So we're on a scale of 1 to 10, where are you on this problem? 2. All right, so you're gonna have to keep practicing it. I'll put this out on Canvas so you can practice it. It really is the key is if you understand the formula, it's just crunching numbers. You guys make sure you're comfortable on the numbers. Are you more comfortable on this than this massive payout? Do you think you can get the premium? It's just you can't get all of this. This is a small part of the problem. So if you can get the premiums, this is all you miss on the exam. It's not going to hurt you all that much. But I like this because it really shows you what a net premium is. That's what it's all about. You're trying to get to a 0 at the end. Any questions on the initial premium that you just have to learn? If this were a 3-year term, it would look exactly like this with one exception. You wouldn't have that. So you can see these policies are going to look really, really similar. If it's a 3-year level term, it's going to be exactly this formula. You just won't have this L43 at the end. So level term is 3-year level term. You're going to see D40, D41, D42, L40, L41, L42. If it is a ordinary whole life at age 97, you're going to have D97, D98, D99. You're just going to keep, I'm not going to give you a whole life at age 40 because that'd be too many D's have to write down. All right, let's look at the second problem. I do have a review video that does these as well, so you'll have to.
You have it on YouTube, right?
Yeah, I'll bring it over to our channel, but you'll have this one as well. So I'm gonna have to edit this video down so it's not a lot of just dead space, but I'll edit it down. Right, this one's not as bad as it looks, and you're probably gonna get more and more look more like this. I don't like the one I put in the notes, so I need to take that one out. That was a pretty tough question. But if we look at this, let's start with the denominator because that's the easiest part. So you're gonna pay a premium at age 25, 26, 40, and 41. Y'all see that? They pay a premium at beginning of 25, 26, beginning of 40 and 41. So the denominator is going to be what? What's the first thing in the denominator? Premium payers. Who's the first premium payer here? So L25, and then what's the next one? Divided by what? 1.05, and then what's the next one? Oh, 40. So here's the trick. What do we divide this by? So remember, if it's at the beginning of the year, premiums are always beginning of the year, you just subtract. What's 40 minus 25? 15, all right? You just have to memorize that. If it's premiums or payouts to livers, that's at the beginning of the year, you just subtract. 40 minus 25. If it's a death claim, what do? You subtract, you have to add 1 because it's at the end of the year. All right, if you remember that, this is pretty straightforward. So tell me this next one. What's this next one then? Someone say it. Just
L40.
41, and then here's the trick, divided by what? 16. Exactly, yeah. 41 minus 25 is 16, right? If you remember that, that makes a big part of this. And you get a lot of partial credit just for getting that much. You might get 25% just for getting the denominator down. The numerator is what you're paying out. So look into the problem and see what you're paying out. Say it pays 3 million to anyone alive at 85. Is that at the beginning of the year or end of the year? Livers are always what? Beginning of the year. So you're going to subtract and add 1 or subtract? Just subtract, no adding 1. Lump sum of 5 million, those at age 90. Lump sum of 10 million, those at age 95. This looks really similar to what we've done before. So your numerator, what's the first thing in your numerator? Which L or D? 85. Because what is it? Is it livers or dyers? It's livers. So it's L85, and we divide it by what? Oh, I'm sorry, times 3 million divided by what here? It's L85. When did we start? It's the beginning of the year, 60. All right. Let that sink in. You're paying at 85, 3 million bucks. So in the numerator, you're going to have whom you're paying to, whether it's L85 or D85. Here's L85 because it's anyone alive, times how much you're paying them, divided by 1 plus the rate. This isn't to an L, so it's beginning of the year, so you just subtract, you don't add 1. If we paid it to people who died at age 85, then we would do D85 times 3 million divided by 1.05 to the 61st. But this is the liver, so we just take 85 minus 25. Right? Let's see if y'all can get this next one. What's the next one? Well, 90. This one's 5 million. You got one last one to do. Yeah, so that's the formula. I won't make you calculate the number here because it can take some time. I'll show you the answer. You can check your work. I can't put the mortality table on here, but when I print it, when I paste it to Canvas, you'll have the mortality table here at the bottom, so you can look up the numbers. Now, I've had more than one student ask if the mortality table will be provided on the exam. I felt like saying, no, you got to memorize it, but no, you don't have to memorize the mortality table. So that would be, but they were asking if they had to memorize the mortality table. So I have some students who think I'm far more evil of a person than I, that kind of shocks me, but anyway. Right, on this one, I get, when I do this problem, maybe I can snip it all in there for you so you can see. You can practice. I get 16,767.21. Now, what I do when I do the exam is I do double check it to make sure. So on this one, I take the people alive at 25. I start with 0. The L25 sums at 16,000. I get that. I then invest that at 5%. The next year, I add another premium and invest that at year 40. I get another premium, year 41. I invest in those. Then at age 85, I pay out 54, but it's at the beginning of the year. Okay, that's how I check it. If I'm a death claim, it would be at the end of the year, and I would actually multiply the beginning by 105, but I would subtract the death benefit without any adjustment. Here, because it's paid at the beginning of the year, I take the beginning balance, there's no premium, and I subtract it, and I multiply all that by 105. I do that again at age 90, again at 95, and end up at 0. So I do double check to make sure I got the right answer. But boy, you can get 80-90% credit. Just writing this out will get you pretty close to all credit, because I know the math. There are a lot of numbers, it's a lot of calculations, but if you're understanding the 60, 65, 70, So the only thing to be careful, if I give you a death claim, you'll have to add 1. That's all you got to remember. But other than that, you just look at that and you see how important that initial year is, 25. Everything comes off of that. You're either going to subtract 25 or you're going to subtract 25 and add 1. That's all you got to really decide. Once you get the ends, you just got to make sure everything that's paid out is in the numerator, all the premium payers in the denominator. It becomes really straightforward. It's really not that complicated of a problem. You've never seen this before, so it's all new, but once you do it a few times, you start seeing, wow, this life insurance pricing, it's the same thing over and over again. You just got to get the livers and dyers all with the right end. All right. Any questions on that one? All right.
The premiums go on the denominator, is that where they go, or?
Yeah, your payouts are in the numerator, your premium payers in the denominator. So there's dollars in the numerator, there's never dollars in the denominator. That's always just people. You're just adjusting for when they're paying the premium, but there's no dollars. So all your dollars should be in the numerator. You will be discounting both of them. So that's why I talk about it. You're actually discounting people here in the denominator, but just taking into consideration the timing of their payment. Any other questions on that one? Let's do one more. So these are it seems intimidating, but these are the 3 toughest questions on the exam. So you can practice these and get them down the rest of the exam. Most students on the rest of the exam they're like, give me points. So if you can get these 3, you're in pretty good shape. I think we have enough time. Let's get started on this one. Maybe we'll finish it next time. So here, the steps you got to work back here is we have this policy that pays if one person dies, the other person dies, or they both dies. So the thing to remember here is the only time it doesn't pay if they both live. So the first thing you want to calculate is the probability both live. That's going to be a P times a P, R, it's going to be an L over L times an L over L. So up here, you have one who's 92. So you're going to do L93 over L92. L93 over L92 is the probability the 92-year-old will live 1 more year. All right, L93 over L92. The second spouse is 94. So what do I put here? L90, which one? L95, L94. All right. So you start with that. That's going to be the probability they both live. What's the probability one or both die then? It's going to be 1 minus what? Well, the probability they do what? Both live, what we just calculated. All right. So we're trying to calculate the probability that one or both of them die. That's 3 different calculations. So we're going to save time and just say, hey, let's just calculate what's the chance they both live. Then we know 1 minus that is the chance that one or both of them die. Right? So we start with that. So then you take the face of the policy times the probability one both die divided by 1 plus the rate. All of that. That's really all you got to do. Pretty simple formula once you get it set up. So this is the premium from the joint life policy equals that. The face of the policy here, it's $10,000. The probability that one or both die is this right here.
The 93 is because you're adding one? Sure.
Well, it's the people alive at 93 divided by people alive at 92, which is what? Your probability of living 1 more year.
Oh,
It can get confusing because it looks like L93 is greater than 92, but it's not. L93 is a smaller number than L92 because we're talking about number of people alive at 92 versus 93. So you can get a number like 0.94 or something like that. Right? That's the premium is the face. It looks a little different than other premiums because we're dividing by the L's here to come with these probabilities. So we don't have to divide by the L's because we've already done that. the face times the probability one or both die divided by 1 plus the rate gives you the answer. So the probability one or both die, I get 47.42, but you can practice it this weekend. See if you can get that. So here you get $10,000 times 0.4742 divided by 1.04 plus 10,000 times 0.4742 divided by 1.04. You get that number. If you don't round, you get this number. I can try not rounding and see if I get exactly that number. Yeah, so if you round, you'll get a number of by rounding, you go out 4 decimal places on the probability, 47.42, you get 45.59.62. I'll let y'all practice that one. So that's the first half of this problem. This problem is, the formulas are much simpler on this problem. So it's really just remembering to do this first part up here. And then you can compare that to 2 term policies. So the 2 term policies, you've got 10,000. This goes back to traditional formula. So you got D92 times 10,000 divided by 1.04 divided by L92. That's that old traditional formula we've been using. That's one person. The second person is D94, L94. So that's the old traditional. You take the death benefit, you take the number of dyers times the death benefit divided by 1 plus the rate divided by the premium payers. That's that old traditional policy we've been talking about. When you do that, I'll let you check it this weekend, see if you can get these numbers. 2435.35, 2845.37. The sum equals 5280.72, or somewhat higher, right? 45 versus 52. So a difference of 720.66. That's your 5280.72 minus 4559.62. So if you bought the joint policy, it only pays you 45, it only costs you 4559.62. If you buy each of them by their own policy, it costs you 5280.72. A difference of 720.66. And this is where you get full credit. You can get pretty close to 80-90% if you do that. But the real kicker here is justify that difference. Anybody remember what's the only difference in these 2 policies? When are they different? It's when they both do what? When they both die. So you say probability both die is going to equal D92 over L92 times D94 over L94. And that's going to equal 7.49%. You take $10,000 times 7.49% divided by 1.05. You should come up with that difference. It's going to round, it's definitely going to destroy it, but oh, I'm using 104.5, excuse me. I don't know why on this exam I was using 4%, so that's throwing me off. So yeah, sorry. That's probably really messing up. Did I do that anywhere else? Hopefully not. And that gives you the 720. Right, so you need that. You need this difference. If you can handle it, you can justify that difference. And the last thing is the rationale, or your advice, I guess is what we should say. We talked about this last class. We're very young. no need to buy joint life because difference in premium is extremely small. Why? Because probability both die is extremely low. All right, that's the first point you made. For seniors, can make sense by joint and save the premium, assuming if both die does not create some additional issues or errors. So if it doesn't matter, if one dies or both dies, the 10,000 bucks is what they need. They're gonna do whatever with it. Maybe they're buying this policy that, so if one dies, the other has 10,000 bucks because one pension's gonna go away, something along those lines. Then yeah, just buy the joint life. If, however, the purpose of this insurance is to pay for the funeral costs, and that's its whole purpose, what happens to your funeral costs if both people die? Probably gonna be twice as much. So in that case, maybe you go for the two-term policy. So you make sure you have 20,000 there so they both die. That's the kind of discussion you have. So if there's no impact on the heirs, whether one or both dies, then you'll save the money. They just need that 10,000. And I think the real key here is that the focus is on them, not on their heirs. The whole reason they're buying this policy is for them to protect each other and just save money and buy the joint policy. If there's some implication for the heirs, if they were to both die, then you'd have to stop and think, maybe we do need a two-term policy. So that's what I'm not looking for a major. There's no essay on the second exam nearly like this is about the only place. There's one other place you have a little bit of an essay, but there's no massive, and there's nothing on the exam you submit in advance. So it's all in class. So I'm not looking for anything like, y'all were freaked out on the essays on the first exam, but there's nothing like that on this exam. It's mainly a math exam. All right. So y'all work on this and we'll come back on this and see if y'all can get these numbers to get some practice. I'll put this out on Canvas so you can double check your numbers. If y'all need more problems, I'll provide some YouTubes that you can get some more practice. All right, we'll stop it there. If you want an extra copy of it for practice, you can do that. I'll put it under the exam reviews.